angular velocity, first of all, a new word for you. Don't worry too much about what it exactly means, but just like velocity means something like distance upon time. Yes or no?
Yes.
Similarly, angular velocity, its symbol is omega. This is how you write. Okay? In 10th standard, you used to write something like this. That is actually capital omega. In Greek letters also they are capital and small. So this is small omega, and that is equal to angle rotated divided by time. Just like the distance traveled by time or that kind of thing. This is angle divided by time. Okay, so this is the formula of angular velocity that we can use for dimensions. Alright? So using this we'll find out dimensional formula. So let's start. Now dimensional formula of omega will be equal to dimensions of theta upon dimensions of t. T for time. Yeah. What are dimensions of theta? Theta means angle, no dimension. Is that clear, everyone? Okay, that's one of the rules. Alright? So nothing here. Divided by means m raised to 0, n raised to 0, t raised to 0. We write like that. Divided by t for time. So this would be t. Clear?
Yes.
The final answer will be m raised to 0, n raised to 0, t raised to okay. Got it?
Yes.
Let's go to the next one. Number 14. No, sorry, 13. If the dimensions of a physical quantity are given by m raised to a, n raised to b, t raised to c, then the physical quantity will be, it will be force if E is 0, B is 1, C is minus 2, like that. So you have to check which option is correct. Make sense? Or not clear? Why don't you try it yourselves? Look at option A. If A is 0, B is 1, like that, you check whether is it force or not force. Not force. For force, what are the dimensional formula? N raised to 1, N raised to 1, T raised to minus 2. It's not that, right?
Yes.
So like this you check which one is okay.
B.
Second option.
Yes.
Pressure. A raised to 1, B raised to minus 1, and D raised to minus 2. Yes, correct. M raised to 1, N raised to minus 1, and D raised to minus 2. Understood?
Yes.
Right? So, if you remember the dimensional formula of pressure, that's all you need to do. Now, number 14. Which of the following is incorrect statement? Make sure you read the question carefully. You don't have to select which is right. You have to select which is wrong. Okay? So we should do it stepwise. First one, A dimensionally correct equation may be correct. True?
Yes.
Who says true? Okay. May be correct. Right? Can you give an example, Rudra, of a dimensionally correct equation which is correct? F equal to ma. Okay, very good. So we can say that F equal to ma is a dimensionally correct equation, and it is also actually correct. Very good. Sit down. So is A correct sentence or a wrong sentence?
Correct.
So is it the answer?
No.
No, not the answer. Okay, be careful. Because sometimes it happens in exam. You read the first one right. First is correct. Done. Only at home you will realize, well, we have to find the incorrect one, not the correct. B. Come on. What is it? Dimensionally correct equation. Maybe incorrect. What do you think? Can a dimensionally correct equation be incorrect?
Yes.
Yes. Who says yes? A dimensionally correct equation may be incorrect. Yes, Amma, can you give an example?
Energy equal to 2mv square.
Sorry, energy equal to?
2mv square.
Okay, something like E is equal to 2mv square or K equal to 2mv square, for example. Okay? Right. This is dimensionally correct. Yes or no?
Yes.
But it's not actually correct. What's the actually correct equation? K equal to half mv square. Is that understood or not?
Yes.
Right? That's because the number 2 and the number half both do not have dimensions. Got it? So it doesn't matter whether it's 2 or half. Dimensionally, they are both correct. But this one is not a correct equation, but the second one is a correct equation. Is that clear?
Yes.
Sure. So is this second sentence a true sentence or false sentence? True. So that's not clear. Everyone gets that?
Yes.
Let's go to the third one. What is it?
Dimensionally
Incorrect equation. Maybe correct. Yes or no?
No.
Yes or no?
No.
Who said no? Okay. Others need to read the book. Put your hands up. This is something that I've made you write. If you read your notes, you'll get it. Find it out. Come on, those who don't know about it. You got it? Okay. Find it everyone in your notes if you don't remember this. So dimensionally correct equation will always be incorrect. That's what we have written. Sorry, dimensionally incorrect equation will always be incorrect. Is it fine?
Yes.
Okay? But this option is saying otherwise. Right? It's saying opposite. That means this is the wrong sentence. Clear or not?
Yes.
So the answer will be C because that sentence is wrong. Okay? Let's go to the next question now. If you have found that sentence from your notes. Number 15. Two physical quantities of which one is a vector and the other is a scalar. Do you remember what's a vector? Vector is something that has both magnitude and direction. Is that okay or not okay?
Yes.
You don't get that? Scalar is something which has only magnitude. Frankly, you have not studied a lot about scalar vectors in 9th standard or even 10th standard. Don't worry about it. Okay? We are going to study in full detail about vectors and scalars in chapter 4. Okay? So right now, I'll just help you decide whether it's vector or scalar. The dimensions part, you'll have to do it on your own. So let's start. So first of all, A. Work and energy. So this question is telling you that these two things must have the same dimensional formula. Okay or not? And one should be a vector and the other should be a scalar. So two requirements are there. One, both have same dimensional formula. And another requirement is one is a scalar and the other is a vector. Okay, both should be there. Only then their option will be correct. So first one, work and energy. What do you think about dimensions? Do they have same dimensions or not same dimensions? Same dimensions? Sure.
Yes.
We have it in the list. Isn't it?
Yes.
They have same dimensions. Now, so it's time for vector scalar. The truth is, both are scalars. Okay? Both are scalars. Okay, why both are scalars? I'm not going to explain right. It will come at appropriate time. Okay? But work energy both are scalars. That's why A is not the answer. Let's go to B now. Torque and work, do they have same dimensions? Yes?
Yes.
Sure. Do you remember dimensions of torque? Who remembers dimensions of torque? Was it on our list?
Yes.
It was?
Yes.
No, it was not in 10.
Extra.
Sorry, appendix માં તો 94 આપ્યા છે. બરાબર ને? તો બધા થોડા ગોખી નાખશો. That's why I told you, you just need to remember the 10 that I said, nothing more. But you can find it for torque. Okay, those who don't remember, like I don't remember, you can find it for torque. Torque is roughly speaking force multiplied by distance or force into distance. Is that okay?
Yes.
Find it out, come on. If you don't know dimensions of torque. Done? How many of you did it? Okay. Right. And the answer is n raised to 1, n raised to 2, e raised to -2. Clear or not?
Yes.
Force has n raised to 1. And then distance is once again one more l. So total l raised to 2. Got it?
Yes.
Right? This is exactly the reason why I tell you to remember a few. Suppose you don't know force also, then you'll have to go all the way back to velocity. You get what I'm saying? Right? But if you remember force, you can come to this in one step. But yes, then you should not try to remember everything. Because the more you remember, the more mistakes you will make. Right? Okay, so this is taught. Is it same as work's dimension?
Yes.
Yes or no?
Yes.
Sure?
Yes.
Who's sure about that? That this is same as work's dimension? Work. Others, you definitely need to remember the date. Okay? You never know when I will ask you. Put your hand up. That's right. This is same dimensions as work. Okay, now torque is actually a vector and work is a scalar. So this will be the correct option or correct answer. Clear? Torque is a vector. Again, why is torque a vector? That will come later. There's just one thing that I want to mention. We are solving assignments and everything. When you have a test, any of these questions will not be asked in exam. Is that clear? I'm making it very clear. Any of these questions will not come in exam. Then you might say, sir, what's the use of solving these questions? This is a major difference between high school and higher secondary school. Right? In high school, you were probably told that, okay, this is your workbook, this is your textbook, do it. Okay, some questions done by the teacher on the board, that's it. That's your syllabus. Now in higher secondary, any question related to this concept can be asked. Is that okay? So aim is never to remember the answers, but always to understand how to get the answer. Did you understand? Okay, so please do not try and remember these answers. Okay, I guarantee you that I will not ask a single question out of this. બધું અલગ જ હશે પણ બધું આના જેવું જ છે. Okay? Clear? Alright, so how to solve is much more important than, hey, what is the answer of this question? Clear? I don't really care whether the answer is A, B, C or D. If you tell me, sir, I've got all the answers, then I'll not even say very good. In fact, I'll ask you two more questions. How did you get it? You understand what I'm saying? I'll ask you counter questions. How did you get it? Okay, so solving 10 with making sure that you understood the method very well is more important than solving all the given questions. Clear? Okay? So please don't fall into that kind of method ever. Yeah, I have to tell you because it just come from 10 to 11. Right? The method just changes. Alright? Okay, so let's continue now. So this question number 16 is the dimensions of electrical resistance. Okay, question 16. Dimensions of electrical resistance. Now, you would have studied resistance in 10th standard. Yes or no?
Yes.
Yes or no?
Yes.
Anyone remember the formula which includes resistance? Some very famous law. If you remember. Okay, law that you have studied in 10th standard. Yes, Risha?
V is equal to I.
V equal to IR. Which law is that?
Ohm's law.
Ohm's law. Yes or no?
Yes.
Yeah, that's okay.
Yes.
Who did remember this? Raise your hand. Then I'm going to ask you, why didn't you raise your hand earlier? Okay, don't be shy. Sit down. Well done. Don't be shy. Again, never worry about right or wrong. Okay? You are here in the class. You have lots to learn. So V is equal to IR. The Ohm's law is what we are going to use to find out dimensions for resistor. What's the other way I could tell you? Find it from the table. In the table, you have 94. One of them will be resistors. Okay? If you are inclined to look at it or find it from the table, I would say you are in the wrong class. Okay? Do not try to see it. Instead, learn how to find it on your own. Current. Easy one, isn't it? Current is one of the 7 fundamentals. Yes or no? Its dimensional symbol is A. Ampere. Clear or not?
Yes.
Okay.
Yes.
Alright?
Yes.
V. Potential or voltage. Do you remember any relation that you have studied in 10 which includes V? V is not volume, by the way. Yes, Raghav?
E is equal to W upon Q.
V equal to W upon Q. Anyone else? Do you remember this? No. W is Q into V, work, charge, and potential or voltage. And V is equal to W upon Q, like this. Clear? We are going to use it, we are going to put it here. So therefore R will be equal to, what should I write if I put this over here? You tell me. What should I write? Huh? Put this here and see what you get as the next step. Come on, do the steps yourself. Hurry up. Pen chalao. Everyone. Done. R is equal to, if I put V's value over here, this is V's value, isn't it? Let's put it here. Then what do we get? R is equal to W upon I. Anything else? QI, W upon QI. Yes or no?
Yes.
Yes or no, everyone?
Yes.
Sure? Or not sure? Sure. Math to avadete yaar. Na no pado. Okay. W upon QI. Now, time to put dimensional formula for all. Just one thing, charge. We don't have a dimensional formula for charge. Do you remember any relation of charge with current? Raise your hand. Any relation of charge with current? अब we एक chapter में then. Okay. Relation of charge and current. Yes.
I equal to Q upon T.
I equal to Q upon T. Yes or no? Everyone. I is equal to Q upon T. How do you do it?
Yes.
How do you do it? So Q is equal to IT. Clear? Q is equal to IT. So how do you do one? R is equal to W upon. Instead of Q, what should I write? Yes. So I into I square. T. Understood? Clear or not?
Yes.
Okay. So from here on, you can find the dimensions. Start. Our formula H is equal to I square RP.
Yes.
How many of you knew that? Okay, 40 minutes page. 90 चालू करो. Okay, this is same actually. Right? Nevertheless, now nothing can be done about it. So find it. Come on, dimensions of work. You know that. Dimensions of current. What should we write for current? A. Clear? T for time. What's the symbol? Dimensional symbol for that? Capital T. Yeah, do all that. What? Questions हमारे solve कराना जो मारे नहीं. Remember that. Okay. So try to do it before I do. Hello? Done. Okay, how many of you finished? Okay. Put your hands up. Alright. Miri, what's your answer?
M raised to 3, T raised to minus 3.
Just a second. M L raised to 3. E raised to
minus 3.
and
A raised to minus 2.
who agrees with her? M L raised to 3. D raised to minus 3. A raised to minus 2. Which option, by the way? B.
C option C.
C. Okay. Who gets this answer? Everybody got that answer? Sit down. No problem. Let's see. Doesn't mean you are wrong. We still don't know. Others?
M raised to 1, L raised to 4, T raised to minus 3, and A raised to minus 2. Option B.
So it is saying B. Who gets this answer? Okay, very good. Right. Sit down. Who gets a further different answer? Anyone? Not this as well. Again, that doesn't mean you are wrong. It's possible you are right. Okay, I've seen so many cases like that where only one student gives one answer and everyone else is wrong. Anyone? No. Come on, how is it possible that you don't get an answer? You would have got something, A, B, C, D, something. Like I said, your pen first, only then my pen. Is that clear? If you are waiting for me every time, sometimes you can wait for me because you don't know. But if every time you are waiting for me, alarm bells should ring. Okay, and in that case, I'd like to consult your parents as soon as possible because then we don't want you to be in trouble of any kind. Yes, I got A. You are A. Let's see. W, m raised to 1, l raised to 2, t raised to minus 2. Clear or not?
Yes.
Divided by I square, that is a raised to 2. Yes or no?
Yes.
And t time, t raised to 1. Okay, so now we have to divide them. When you divide and multiply, powers are added, subtracted. Clear? That rule you cannot forget it. And I am not going to teach it again. Okay, if you want, you can learn it from your friends. I am not going to teach it. Those who did not get it earlier. Well, here. M raised to 1, L raised to 2. Now t raised to minus 2, minus 1, that is minus 3. And a raised to 1 upon a square means a raised to minus 2. Yes or no?
Yes.
Okay. Clear?
Yes.
Billy, you got an extra L from somewhere. Isn't it? Right? Fine. So the answer will be which option? B. Okay. Seventeen. Wave number. Shall I raise it? So 17th question is about wave number. Now, possible you might be knowing what is wave number, or possible you don't know. Anyone knows what's wave number? Anyone knows what's wave number? No problem. Wave number is reciprocal. Reciprocal means inverse of wavelength. Wave number is reciprocal or inverse of wavelength. You know what wavelength? Yes or no?
Yes, sir.
When you have got a wave, the distance between two consecutive crests. જો આ ડેફિનેશન તો તમારી યાદ રાખેલી હશે. એકલું 9th માં ચાલતું હતું. બરાબર ને? હવે એ ડેફિનેશન ના બધા યુઝ 11th માં આવશે. That's the difference. Well, n is 1 by lambda. Now you have to find dimensions of wave number. Come on, this is wave number n. But you have to do it yourself. Do it yourself. This is wavelength again. Wavelength. Come on. Done?
Yes.
What's the answer? L raised to minus 1. Yes or no? Sure. 1 is a number. Has no dimension. Wavelength has dimensions of length. Obviously, it's a length. Clear?
Yes.
Sure?
Yes.
So final answer will be dimensions of n or wave number are L raised to minus 1. Everything else is 0. Okay, let's go to the next one. Okay, the method of dimensional analysis can be used to derive which of the following relations. First of all, let's understand what dimensional analysis can do and cannot. For example, if you suppose you realize that, let's say in some case, somehow, suppose the formula of kinetic energy was 6 mv squared, for example. then the problem is that this 6 is a number, yes or no?
Yes.
And dimensional analysis cannot make any distinction between 6 and half, because half is also dimensionless and 6 is also dimensionless. Clear or not? Sure. Let's take another example. Suppose you have got something like maybe y equal to a sine kx, for example. Okay, I'm just writing random equations. All this will help you understand the question. If you have got something like this, sine theta, this whole thing is dimensionless, correct or not?
Yes.
So even if instead of sine, if it was cos, it would not make any difference to the dimensional analysis, correct or not? Because sine theta dimensionless, cos theta, do you remember that?
Yes.
So basically, whenever we get such dimensionless things, that cannot be proven using dimensional analysis. For example, you may prove f equal to ma. You can get f equal to ma using dimensional analysis, but you cannot get f equal to 2ma using dimensional analysis. What's the problem here? 2 is a number. It doesn't have dimensions, so it will not show in the dimensional calculation. Clear? So basically, anything that is dimensionless creates a problem if you want to derive. You get what I'm saying? Anything which is dimensionless creates a problem. So the question says that out of all these, which one can you derive using dimensional analysis? Right? That it should not have anything which is dimensionless. Let's go to the first one. N0 e raised to minus it or something is written. Is there something that is dimensionless over there? Is there something that is dimensionless? What? Power. Yes or no? Do you remember powers are dimensionless? Is there a problem? Yes. Okay? Okay or not okay?
Yes.
So that's not going to be the answer. Then second one. Sine. Dimensionless?
Yes.
Same problem. It could be cos, it could be tan also. We would never know. Okay. Next. Half and also addition. You get what I'm saying? Right? Dimensionally, half mv squared plus half I omega squared. W squared, what is given there? And half mv squared minus half I omega squared. They are same, yes or no? Because whether you add or subtract, the dimensions have to be same. That's it. The same rule applies. So there is no way you can decide whether it will be plus or minus. Make sense? Right? So this is a thing again that cannot be caught by dimensional analysis. Again, half is also a problem. There's no doubt about it. Right? So there are multiple problems. Then the answer will be none of these. Sorry? Stand
Sir, could you please explain dimensional analysis again?
Are you sure you want me to explain that whole thing?
Sir, I got
It might have got 2 or 3 lectures
sir, only the dimensional analysis.
of
The question of the just now.
this one.
Yes, sir.
Only option C.
Also, the explanation is about dimensional analysis.
Okay, do you know the 3 rules for dimension?
Yes, sir.
Say them or read them from your book.
Sir, if the angles are dimensionless, numbers are dimensionless. It has to be written in square bracket, and the sign cos then are also dimensionless.
Okay. One thing more. If you add or subtract,
That also dimensionless.
yeah. When you add A and B and you get C, that is A plus B is equal to C. That means dimensions of A, dimensions of B, and dimensions of C are going to be same. These are the rules. Okay. But numbers don't have dimensions. Correct or not? Okay. So all the numbers in the equation, they can never be obtained by dimensional analysis. For example, you can get F equal to ma because it doesn't have numbers. It only has force, mass, and acceleration. But k equal to half mv squared. You can't get it by dimensional analysis because by dimensional analysis you can only get k equal to mv squared. Clear or not? Clear or not? but half will miss out because half is a number, it doesn't show it the dimension. Got that? So just like this, whenever there is anything which is dimensionless, it will miss out. Okay, so you cannot get that equation. So can you get a sin kx? No, because there is sin. Can you get a cos kx? No, because there is cos. So basically you cannot decide whether the equation will be this or will be that. Clear? Okay. Same thing here. Plus or minus, the rule is same. So like that, in all the three we have a problem. Something that is dimensionless. Clear? Let's go to the next topic. Next question. The Bernoulli equation is given by P plus half R V square plus H R G equal to K. Big equation, isn't it? Lots of terms are explained. What is P? Charge, speed, and height. Okay, G is gravitational acceleration or acceleration due to gravity. And K is some constant. Okay, K is some constant. Now, the question is, the dimensional formula for K is same as that for. That is, first of all, we have to find dimensional formula for K. And then we have to see it's same as what? Is it same as velocity gradient, pressure gradient, etc. etc. Clear? Clear or not? The first task should be to find out dimensional formula of K. Give it a try. Think about the rules. Which rule looks like it is applicable here? Raise your hand. Rules for dimensions. Which rule looks like it is applicable if you want to find dimensional formula of K? Okay. Yes.
Dimensions of A plus dimensions of B is equals to C. So dimensions of A, B and C should be equal.
So when you add A and B, you get C. Then dimensions of A, B and C, they are all equal. Okay. Sit down. Well done. So rule number 3. Clear or not?
Yes.
Okay. Rules for yaad hata. I just want to ask one simple question. How many of you do remember the rules? Okay. Well. See, it is that often we have to do problem solving. We have to solve questions or we get into some tricky situation. Let's say somehow, due to whatever reason, this door doesn't open. Okay? Then there are so many options for us. We can break the door, we can take a screwdriver and open these hinges up, okay, and get the door down and walk out. Or we can open the window and jump through it. Is that okay or not okay? We have so many methods, so many tools. On a normal day, you will be able to understand or think about all of it. Clear or not? Yes or no? So all these possibilities, all these weapons are there with us, you could say. All these methods are there. Just like that. Most of you knew about the 3 rules, yes or no? They were just lying over there in your pocket. You had to use it. So you have to develop that judgment. કોઈ તમને કહેવા નહીં આવે ક્વેશ્ચનની બાજુમાં લખેલું નહીં હોય. Use rule 3. You understand what I'm saying? So once you know the rules, the next step is you have to learn how to use them and when to use them. Okay, you can open this door with a hammer and you can also open this door with a nuclear bomb. Is that okay or not okay? Okay, but in different situations, different tools are useful. Got it? So you have to learn when to use which rule, when to use which concept, and when to use which formula. Clear or not clear? Right? So like here, you remember the third rule. Fine, very good. But you should have judged it. That's what you have to train yourself. Okay? અને ફરક ઈ જ છે 10th માં છે ને ચેપ્ટર માં 2-3 જ ફોર્મ્યુલા હોય ગમે એ હોય એ કરી નાખો આન્સર આવી જાય નહીતર ક્વેશ્ચન માં આપેલો હોય સપોઝ રેડિયસ ઇઝ given and you have to find area of circle. It becomes very clear that you have to use area of circle formula. But now things are not so direct. You understand what I'm saying? Nobody tells you what you have to do. You have to think about it and then you have to do it. So rule number 3 is suitable because there is addition. I'm sure those who said that we have to use rule number 3, they judge it by this fact only. There is no other magic. ये लोगों ने कहीं secretly खबर नहीं पड़ी. You understand what I'm saying? Do you see addition everywhere? Yes. That's it. That's what you pick. Rule number 3. Is that clear? Sure?
Yes.
Now go on. Train your mind to do this. Okay? It will not happen in a day. But yes, within a week or so, you'll definitely be able to see the result. Well, use the addition rule. Find out dimensions of K. Come on. Raise your hand when you are done. Find dimensions of K now. That would be the first step. Raise your hand when you're done. Okay, put in. Use the easiest one to find dimensions of K. Okay, there are some difficult ways and some easy ways. Again, don't do it like I said. दरवाजा खुलो है तो बारी માંથી કૂદવાનો જો. Okay, be careful. A, B, and C here. Anyone else found dimensions of K? Come on. Okay. Disha, then explain how you did it.
Sir, this pressure dimension formula is n raised to 1, n raised to minus 1, and
E raised to minus 2. Okay, yeah, fine.
is directly is equal to K.
Yes. Is that clear or not clear, everyone?
Yes.
This is rule number 3. Isn't it? When you add some things, then what? Dimensions of each of them are same as what you have on the other side. Correct or not? So what do we have on the other side? K. So dimensions of pressure are same as K. Dimensions of something like HRG are also same as K. But like I said, this is like jumping out of the window even if the door is open. This is the door, open door. You don't have to do anything. Clear or not?
Yes.
आज सीखवाना है. समझ पड़ेगा ना समझ पड़ेगा? ना समझ पड़ेगा. If you have added few things, all have same dimensions. How many terms are added? P is added. What else is added? Half RV square plus HRC. So all of them are added. So individually, each of them all have same dimensions as K. Yes or no? Yes. પણ આ બધું ન કરવા જવાય. Clear? It's not wrong, but it is useless. This is simplest. Clear? Yes. Well done. Sit down. 80 seconds નું કામ હતું તમે વિચારી જોજો. How much time does it take to realize that okay, this is and this is that same? You don't even have to do calculation. Now comes the calculation. A, B, C, D. 4 options are there. Let's start with option A. We have to see which one has same dimensions as K. Yes or no? First option is velocity gradient. Velocity gradient means what do you mean of gradient? Equal to not equal to. You cannot afford to forget this.
Change of quantity upon
Change of some quantity divided by distance. Everyone, go home, read the stuff that has been taught. Okay, it's a requirement. How भूली जसो तो नहीं था. Right? Okay. must remember. વાંચવું જ પડશે રોજ. You don't have trust. Okay, 12th માં 11th નું આવશે. Let me be very clear. એક્ઝામ માં નહીં આવે પણ તો એક્ઝામ માં આવે. સમ આપ્યો છે 12th ની એક ફોર્મ્યુલા બાકીનો આખો સમ 11th નો કેતે કરશો. Okay, so you have to remember everything till the end of 12th, each and everything that I am teaching. Now no ચાલે કે તમે 2-3 દિવસમાં ભૂલી જાઓ what is velocity gradient. Okay, gradient means some quantity change. Kato note kato change in a quantity divided by distance. Yes or no?
Yes.
Okay. ને યાદ હોય તો બોલવાનું બેઠા નહીં રહેવાનું. Let the class be interactive. એ તો તમને જ ઊંઘ આવી જશે અને મને કંટાળો. Okay, so velocity gradient will have what dimension? Velocity gradient will have what dimension? Change in velocity upon distance. Change in velocity means v2 minus v1 upon t. Okay, now when you subtract two quantities, the result also has same dimension. Yes or no?
Yes.
હમણાં જ આવ્યો હતો ને rule 3. Is this step clear? v2 minus v1 will have same dimensions as velocity because this is velocity, that's also velocity. Dimensions will be of velocity. Clear?
Yes.
Sure?
Yes.
Or not sure?
Sure.
Answer
X is
is a unit.
minus 1
T raised to minus.
Velocity L raised to 1 t raised to minus 1 upon distance L raised to 1. What's cancelled? The final answer is t raised to minus 1. Does it match with k? Does it match with k? No, you don't match. Is that you? Okay. Try second one. Come on. What's the second one? Pressure gradient. So same thing. Come on. Pressure gradient. Try it yourself. Hurry up. Hurry up, people. Anyone finish? Pressure gradient dimensions? Yes, very good. Over there. What's your name? What's your name? Anjali. Yeah, Anjali. So what's your answer of pressure gradient dimensions?
N raised to 1, N raised to minus 2, and T raised to 1.
T raised to minus
2.
2. Who agrees with her? Yes, that is correct. Pressure on its own, pressure has this dimension formula. Yes or no?
Yes.
And then divided by distance means m raised to 1. So it will become m raised to 1, n raised to minus 2, t raised to minus 2. Clear?
Yes.
Okay?
Yes.
System. Does it match? No. Now there are two more remaining. Fine. Let me tell you about D first. D is written as thrust. Correct? Now thrust is actually another name for force. Thrust is another name for force. Thrust is a kind of force it is. Right? So what are dimensions of thrust? M raised to 1, N raised to 1, T raised to minus 2. Does it match?
Yes.
Does it match? With pressure? Obviously not. Okay? So C will be the answer. But again, like I have said, we are never after the answer. We are always after the method. How is it that C gives same dimensions as pressure? Let's see. First of all, name of the third option, the quantity is modulus of elasticity. What is modulus of elasticity? We'll study later. Right now, we just use one formula that would be good enough for us. E is equal to, E is not energy, E is modulus of elasticity. Okay, E for elasticity, like that. F upon A, L upon delta L. You know what delta L? No problem. Let me write it in a different way. I'll tell you what is delta next. Okay, right now we don't have enough. This is the formula. Force, length, area, change in length. Force, length, area and change in length means final length minus area. Clear? You want to find dimensions of this. Do it. Do it fast. Fourth dimension is how much? Fourth. M is to what? L is to what? A is minus L is length. Length dimension L is to what? Okay. Area dimension L is to 2. Okay. L2 minus L1. Look here. Just like V2 minus V1 has same dimensions as V, L2 minus L1 will also have same dimensions as L. Clear or not? Yes. Okay. So what do we get? What do we get? M is 1 L raised to minus 1 and P raised to minus 2. Clear? Yes. Does it match with K? Yes. So that's clear. Okay, now you can turn this.